solute present in less amount and solvent always present in high percentage. That's why concentration unit. According to concentration unit, as you can see, guys, mass percentage. Mass of solute present in 100 gram of solution is called mass percentage. And this is the formula of mass percentage. W upon W is equals to mass of solute in gram and mass of solution in gram. Volume percentage basically defined by V. Volume of solute present in 100 gram of solution are called volume percentage. As you can see, volume percentage equals to volume of solute in ml and volume of solution in ml. Mass per volume. Mass of solute present in gram and per 100 unit of solution, volume of solution is called mass per volume, and this formula is mass upon volume is equals to mass of solute in gram and volume of the solution in I would say ml. Now molality. The number of moles present in per kg of solvent are called molality. As you can see, number of moles of solute present in the per kg of the solvent are called molality. Number of moles of solute is equals to mass of solute upon mass of solvent. As you can see, molality basically we denote small m, mass of solute upon molar mass of solute into molar mass of solvent. Temperature dependent because it have same volume. Molality always be temperature dependent. Okay. Molarity, the number of moles of solute present in the per liter of solution are called molarity. Molarity will be always temperature dependent, and but in case of molality is not dependent of temperature. Molarity basically denoted by capital M, and as you can see, molarity is equals to mass of solute upon molar mass of the solution into volume of solution in liter. M is equals to W upon M into V. Mole fraction of the component is basically the ratio of the moles of the component to the total number of the moles of component present in the solution. Like let example, A and B are the component in the solution, N of A and N of B of the solution respectively. For the fraction of A chi will be N of A upon N of A plus N of B, and mole fraction of the N of B will be chi B equal N of B plus N of A plus N of B. Total mole fraction of the solution always be unity. Unity means 1. Okay. Now we are study colligative property. Colligative property are those which are dependent of, I would say, those property which depend upon the molecules and amount of substances are called colligative property. Like temperature never dependent on the amount of substance, but now we can see relative lowering vapor pressure and elevation of the boiling point, osmotic pressure and depression of the freezing point. These are the colligative property. As you can see, osmotic pressure, the external pressure of osmosis are called osmotic pressure, or we can say the external pressure by which osmosis process is stopped, then such type of pressure are called osmotic pressure. Now as you can see, dear friends, solution of the solution to solution will be Pb equal nRT, pi equal nst. Now you know this is a notes on a biological topic, semi permeable membrane. Semi-permeable membrane basically is a type of membrane which basically filter, like only I would say liquid particle can be passed by which, and solvent go through solution, and solution dilute, then it will be concentrated solution. Diffusion, flow of particle from the concentration to lower concentration. Semi-permeable membrane absent, it is the solid, liquid and gaseous. Osmosis, pressure, flow of particle from lower concentration to high concentration. Then such type of pressure are called osmosis process. Semi-permeable membrane present here, and in diffusion semi-permeable membrane is absent, and osmosis take place only in liquid state, while diffusion take place all solid, liquid and gas. PV equal nRT, PV equal N upon P equal RT, P equals CRT, N upon V equals C, P into W into RT upon M upon P. That's why. Now isotonic solution. Those solutions which have same pressure are called isotonic pressure. Let us consider A and B are two substance, I would say isotonic solution substances. P of A, P of A, B of A equal NART, and like this P of B, B of B equal NVRT for isotonic solution, and P of A equal PB, N of A RT upon B of A, N of B RT upon B of B, and by this we can prove W upon W into A upon MA into VA equal WB into NB into NB. Now this is vapor pressure. At constant temperature, the pressure exerted by vapor present in the solution are called vapor pressure, and it's also a colligative property. And relative lowering pressure, or we can say vapor pressure. When a non-volatile solute is dissolved into a volatile solvent, then vapor pressure of the solution get decreased. It's known as lower vaporing pressure. Like delta P is equals to P naught into P naught minus P of S. Now you can see delta P is equals to P naught minus Ps. Relative lowering pressure is defined the ratio of the lowering of vapor pressure of the solution to the vapor pressure of the pure solvent. Now you can see Rolle's law basically defined. According to the Rolle's law, for the non-volatile solute, the relative lowering of vapor pressure is equal to the mole fraction of the solute P naught minus Ps upon P naught is equals to N of small m upon N plus N, where small m is the number of moles of solute and capital N is the number of moles of solvent, and P naught is vapor pressure of solvent, and P of S is the vapor pressure of solution. You can see for diluted solution N of M will be only N. You can see P naught minus Ps upon P naught is equals to N of A simplified form like this, where P naught is vapor pressure of the solvent and P of S is vapor pressure of solution, W is mass of solute, and capital W is mass of solvent, M is molar mass of the solute, and capital M is molar mass of the solvent. P naught minus Ps upon P naught is equals to N of N plus upon N plus capital N 1 minus P of S upon 1 of P naught is equal N upon N plus N. P of S upon P naught is equal 1 minus N upon N plus small m, capital M, sorry. P of S upon P of naught equal N plus N minus N upon N plus N. By this we can prove this P naught minus Ps equal upon Ps equal N upon N. Now most important topic is that boiling point, though the temperature at which vapor pressure will be equals to the atmospheric pressure, that is called boiling point, and the elevation of boiling point when non-volatile solute is dissolved into volatile solvent, then the boiling point of the solution increase, and this process is called elevation of the boiling point, where it basically denotes mathematically delta T is equals to Ts minus T naught, where delta T is elevation in boiling point and Ts is boiling point of the solution and T naught boiling point of solvent. Molarity and molar mass, relation between molarity and molar mass. You can see K of B equals moles of elevation constant T of B Kb into W into 100 upon m dash upon into W. Molar elevation constant delta T B is equals to K of B into W into 1000 upon m dash into W. Elevation of boiling point when 1 mole of the solute is dissolved into 1000 gram of the solvent and gram in kilograms are called elevation of constant. Non-volatile solution dissolved into the volatile solution 1 kg, then that will be Kb is equals to delta Tb into m dash into V. Freezing point when an volatile solute dissolved into the volatile non-volatile solution, then the freezing point of the solution get decreased because vapor pressure, it is called depression of freezing point. T of F is equal to T naught minus Ts, where T naught is freezing point of solvent and Tf is depression of the freezing point. T of S is freezing point of the solution. Now you can see molar depression constant, basically depression of the freezing point when 1 mole non-volatile solid dissolved into 1000 gram of, or I would say 1 kg volatile solvent is called molar depression, and this is just proving mathematical proving. K of F is equals to T of F into m dash into W upon W into 1000. Reverse osmosis, basically we can say when external pressure is greater than the osmotic pressure, then pressure of the osmosis take place in opposite direction. That means flow of the solvent from higher concentrations to lower concentration, then such type of process called reverse osmosis. Okay, now we have already required to read Henry law. Henry law basically denotes about the solubility of the gas in liquid is directly proportional to the partial pressure of the gases. S directly proportional to P, where S is solubility of the gas and P is partial pressure of the gas. If solubility of a gas, I would say in the terms of mole fraction, so the Henry law, the partial pressure of the gas directly proportional to the mole fraction of the gas. P directly proportional to x P K H x. K of H is Henry constant. Henry constant, the ratio of the pressure of the gas and mole fraction gas is called Henry constant. Unit tests it have no unit. Okay, and now my dear friends, there are some numerical examples that you have to done.